Hey, hope everyone is well. Looks like we've got a lot of participants rolling in. We're going to wait a few minutes to get started. Just make sure we have everybody on here. While we're waiting, we'd love to hear what where where you're from, what company, and a little bit about yourself, if possible. I'm Amit Patel. I'm from Integ Enterprise Consulting. We also have Rashid Khan here. Rashid, you want to introduce yourself?
Hi, I'm Rashid from Intech. So I'm a solution architect. So I'm going to be one of the panelists, be part of this webinar today. Samit, we wait for a few minutes, I guess.
Sure, let's wait maybe a couple more minutes. Adam, just let me know when you think we should get started. Maybe it's 12 o'clock, so give everybody one more minute and then we'll get started. Yeah, and if anybody has any questions, please put this in the Q&A. I'll be able to see them. You can ask questions as we go. We will address them as possible. If not, we'll wait until the end for the questions. So thank you. Yes, if you're on the West Coast, you'll be having coffee, whereas it's lunchtime here. We're basically right next to New York City here. All right, so we've got 14 participants. We'll wait one more minute until it's 12:02 and get started. Yeah, thank you, everyone. Appreciate everyone joining. Hopefully this will be fun, interesting, and informative and can get you on your journey to automation. Right, we've got 17. Okay. All right, so I am going to get started. If anyone is late, don't worry, there'll be a recording of this. Thank you, everyone, for joining. And again, as Adam pointed out, if possible, we'd love to hear where you're from, what city you're in, and what company you're with. If not, just give us your city, that's fine as well. Today, we'll be talking about streamlining plant operations with automation and machine learning. The agenda, and this is what we call a Power Live seminar. So this is going to be one of 5 seminars, and we'll go deeper and deeper into these, but this is kind of an intro. So we will discuss why plant automation is critical for renewables. Then we're going to talk about, well, if it's that important, why haven't utilities automated, right? We'll talk about the challenges, and there are some real challenges there. And then we'll go into solution review. We'll kind of give you what we think is the suggested approach from, various companies we have worked with and we are working with. And we'll go through 3 actual solutions. Hopefully we'll have time to get through all of them. If not, at least we'll get through the first 2. And then we'll take some question and answer. So as far as key speakers, we have today Rashid Khan. Rashid, I don't know if you want to introduce yourself a little bit.
Hi, I'm Rashid. I'm a managing partner in Intech. My experience has been last 20 years in IT solutions. And I have worked intensively in the last few years in automating plants and especially in the renewable areas, and also involving a lot of machine learning and AI part of the process.
Yes, and then we had Wing Chang, but unfortunately we had to change tracks. So I'll be filling in for Wing, and we also have Dr. Javed, who's a AI/ML machine learning professor, as well on here for any machine learning type of questions. A little bit about Integ. We're not going to go into anything, about what Integ sells or anything. This is more going to be focused on automation, but just want to tell you who we are. We provide solutions to energy and financial clients. We've been doing that over 2 decades, and we're in multiple continents. mostly in the US, Canada, and Europe. For utilities, we work on something called an energy intelligence platform, which is, what we use for a lot of the solutions as well. We've got a huge roster of blue chip clients. Also, a majority of the ISOs and RTOs use our systems. And we also have systems in various generation and other areas throughout the US and multiple ISOs. Sorry, let's get to it. Why plant automation is critical for renewables. Before we do that, we're going to talk about what really automation is in the context of what we're saying, right? It's simply a process going from manual to non-manual. Now, it could be a process that takes, 10 hours, but you've automated it, so now it only takes 2 hours. That's still considered automation. We may never, certain processes, get to 100% automation, but long as you're saving time with the automations, that's sort of great. The targeted operations are going to be digital in nature, typically. And what we want to point out is that, you start small, right? Even 1 hour saved per week across multiple plants can end up in, 6 figures in annual cost savings. So these don't have to be huge, big things, right? And that's actually what we're going to propose here, is that a lot of small changes add up to huge, huge changes, especially in time and cost savings. And really the biggest reason that we see is that renewables companies cannot keep up with the data volumes. So literally a paradigm shift is needed from manual to automated. Otherwise, as companies end up adding more and more units, and as there's actually more requirements from the ISOs now, as you get more renewables, they're becoming more critical. So that means even for the ISOs, they have to know exactly where you are and be able to predict much, much better, because each change makes a big difference to the rest of the grid. So we are going to see even a lot more requirements on top of the current requirements. And the fact that you have, for example, a wind turbine, a wind plant with 100 turbines, you're really looking at each of those turbines, and you have to look at it often individually and then sum it up. So where you would be looking at one plant, you're looking at, the equivalent of 100 at this point. So that's the biggest thing, is the data. Number two, what we're seeing is that a lot of this data is locked up in your Pi and SCADA systems, right? And often, sometimes it has to be real time. It's not as easy as fossil often, where data was in databases, everything was compiled. So that's another big challenge. And the third challenge is, renewables are new, and they're also getting more and more plants are getting added every few months. We have clients where plants are getting added every month, especially with solar and other types of plants. So now that we understand why automation is critical, let's take a little bit of a look as to, why haven't utilities automated, or at least automated to the detail that we believe they should, especially with the tools available. So number one, there is a knowledge gap. While renewables have been around for a while, implementation still is fairly new. Even in the US, the number of solar plants, it's only been a few years until we've had a large number, right? Wind has been around a little bit longer, but for most utilities, having multiple wind plants, it's still only been a few years. So there's a resulting tools and process gap, right? Best practices are still getting created. The tools to address the problem may not necessarily be there. And I'm talking about IT tools and processes also. Now, we can ask, well, let's just buy off the shelf solutions, right? There's a problem in that, and I'll explain a little bit later. There's a lot of smaller problems that you can't keep buying off the shelf solutions, right? You don't have enough people to maintain them, and it's too expensive to buy a tool for every little problem. So they often become only a partial solution. So for some cases it does help, but a lot of cases, it's not going to be the solution that we need. And the second step is there's hundreds of small or lots of small to medium requirements, and there's ad hoc requirements, right? I need to predict this. I need to optimize this. Is the ISO paying me properly here? I need to predict this fault. I need to check these turbine temperatures, right? So for all of these, what happens is that you have numerous differing requirements. Traditional IT is not built for this, but the business isn't necessarily either, right? So because a lot of the data is locked up in Pi and SCADA. Now, what happens is that you may only be able to, the business is only be able to get to a few of those solutions. And when they do, it's like, okay, let's use Power BI. And Power BI is great for visualization, but for a lot of these, especially for automation, it doesn't work. So then you say, all right, well, you have some developers or somebody internally that has Excel and VBA, and that only works to a small extent because you can maybe do a small thing, but if you need true automation integration, just Excel doesn't work for those cases. So really what ends up happening is that solutions either don't get built or they're not truly automations and they end up being static analytics. So really in summary, it's lack of proper tools, difficulty getting data out of Pi and SCADA, and then, lack of IT and business resources that can address these things. So
I think, Amit, I just want to just put in is that, so lately I've been working with very large utility companies, and I think the challenges, as you mentioned, is that especially when you're bringing data in for your ISOs, when you bring data for your NERC GETS requirements, there's a new NERC requirements coming up. And we found out unless and until we automate these things, it is going to be impossible. It's not going to be possible for like how we did in the old fossil units, because the number of events are different. Now you're going to see, I think it's what you pointed out. These are the challenges I'm facing. And I think, and we are in the process of actually addressing those challenges through automations, through machine learning, and other techniques, which I think, Amit, you're gonna cover later on this some of the use cases.
Correct. All right, so let's talk about solutions, right? I'm going to get into some sample solutions or actual solutions, but before that, let's talk about, what the suggested approach is, right? Is start with an agile approach and take baby steps. So step one is, with everything we see, forget the technology, right? Number one is to understand and bridge the IT business gaps, right? You need to review your data needs first, then explore and understand the data. Often just those two steps, as simple as they seem, actually stop a lot of projects, especially smaller projects. You may have folks in Pi that understand their side, then you have the business that understand their side, but them communicating is difficult because everybody doesn't have the same data, or they're not, discussing it in the proper ways. So once you can review your data and explore it, then the best thing is don't build everything. Build a quick prototype that will help you understand what's missing. You may need more data sources. You can get to those. You're going to refine it. And then once you've done that process multiple times, then you can implement it. And then since it's an automation, go into parallel production, because you may have missed something possibly that you'll find in parallel production. And then once we see this process play out, the rest is usually smooth and really simplifies. So for us, the biggest thing we need, and we've seen, is that you need an integrated set of tools. Clients have tools, but you have tool 1 here, tool 2 here, tool 3 here. They are not integrated. What I am going to preach, and if there's any IT folks you could work with or internally, ensure that your tools are integrated and that you can easily get to all of the data that you need, because for what we're seeing, that's about 50% of the way there to getting to a solution.
One point I want to clear, it's important when we talk about integrated, you folks have, I see, Azure and AWS. those are not integrated. When we talk about integrated, you want to have a full stack solution where your ML, your automation, analytics are there, and we'll give you the reasons behind that. Is because if you don't have a full stack solution, each of the use cases you're going to achieve is going to take months or weeks to months compared to days. So, and we'll show you some of the examples in today's use case, and then you can choose the correct whatever the solutions you have within your organizations, and kind of follow what we are doing.
And we'll suggest tools that are in the Microsoft stack as well that most folks have as well, and how to integrate some of those. So aside from those, the other thing that we, for us that's been working is we've started working with a few companies and created more of a collaborative community approach. So I'm sorry. Somebody may need to go on mute. I apologize. But yeah, so we're creating more of a collaborative community approach, right? So a lot of these companies initially, they think of themselves as competitors, but when you look at a lot of these things that need to be solved, right, they're common cases. There's not a lot of, it's not a lot of IP associated with it. So our approach is let's work together, right? We've compiled a list of use cases just within these 4 companies. We have over 50. We've gotten to about 12 of them so far, or maybe 16, sorry. And then we're working on the most hard-hitting common use cases. And once we're done, what we do is we create a recipe book and share it amongst the participants so that they can use it, because everybody's going to have different tools, and you may want to implement it different ways. But if you have the recipe book, then the steps that's needed, and it'll make the process a lot easier. So if anybody is interested in that process, you could just email me here. But the process, again, is that you have the generators, utilities, whoever is interested in these solutions. We identify the use cases. We will work on, solve, and share the solution recipes. And there's no cost to doing any of this. So if you are interested, you can join. But if not with us, we still suggest that maybe you can join with other companies or participants. And then it will really ease the burden and simplify this, because I believe there's a lot to get to, and doing this approach, you can get to it easily, divide and conquer.
So, I think it's more about the Kaggle approach, am I right? In Kaggle, companies are coming in, bringing the use cases, and it's become one of the, I guess, the most important area of ML right now.
Correct. So Kaggle it's just a website where people can, and it leads right into, so for example, if you're doing machine learning, right, the biggest problem is that what Kaggle does is people they put a data set in, sample data set, and then they show the solution right on there. So then if somebody else wants to do it, they can follow along. So to that effect, for machine learning, we also, the more data that you collect, you having one generator or a couple of generators, if you want to do something like machine learning, you need a lot more data to collect, right? And in certain areas, you also want to benchmark. So if you do this community approach, you can also, for example, with the folks we're working with, we're facilitating some anonymous benchmarking and data sharing. And then when we do, even if you don't do that, or your company doesn't allow you to do that, we can share which models work best for machine learning, right? So again, this is all part of the collaborative approach. Don't reinvent the wheel. And if you can work together, it's a lot easier to solve some of these problems. And then again, as I said, we will give you the suggested tool sets as well to get you to automation quickly. In the recipes, we talk about tool sets such as Microsoft Fabric set of tools, and we go into more details. We also have a free version of our tool that's open source based for data exploration. So if you want to use that, I'll show you a little bit of that, but you don't need to. You can use other tools as well. And your IT may have other tools. If we provide the recipes, they may be able to figure out what to do with those. Again, the key is going to be that these tools need to be integrated. And I'll walk you through that in a little bit when we go into the solution. So let me know if any questions before I start the first use case. I'll take a quick 15-second break, and if any questions. Or Rashida, if you have any points to add, go ahead.
No, I think the previous slide regarding the folks who are there is and making sure that to solve these problems, and the solving these problems needs to get done within weeks, not months. So it's very important that if you look tools like Microsoft Fabric or open source based tools, which we have done in a way that it has the entire stack of visualizations, automations, machine learning, AI, augmented analytics, everything needs to be under one tool. And then and only then you should be able to do all of these use cases very quickly. Within a week, you should be able to solve some of the problems compared to months and right now what we're seeing.
All right, so let's get into a use case where a customer saved over 300,000 in call out operations. So what we did, for example, in this set, this is all ISO front office processes. We wanted to, as part of this live series, we're going to work on automating a lot of these and discussing these. This is just one of those under other operations, but we'll talk about all of these. I think we've already talked a little bit about this before, but we're doing this in a series so you can see that, hey, I can take an entire thing that's really large and then try to automate each piece. And once you've done that and linked them, then you have this huge process that involves tons of people that you've automated, right? So we just wanted to, through this series, you'll see this. We'll do this in a small way, but then when we're
the next
done,
one, Amit, is the NERC GATS. I think that's the one we had it last month, but the full implementation of NERC GATS for the renewables is going to be done in the next webinar, which we'll show you the entire implementation, how it's done. I think the last month we just talked about the concept, but we can talk about it in the next webinar. Yeah.
So this manual call out and other processes were causing large losses. So we're doing this with two companies. One still is assessing what the costs are, and they're in the process of implementing. The other company had a lot of units and they had the data, so they were able to assess it, and we were able to implement this fairly quickly. So essentially, for a lot of these plants, when there's faults overnight, they will call somebody out. The whole goal is that, hey, if I need to generate and I'm going to lose revenue, we don't want to do that. So the call out rules were a bit simplistic, and they were using Excel data, and sometimes it was correct, sometimes it wasn't. And because of the processes, they found they had sometimes two people were called in when they didn't need to be. So it was about $64,000 in extra costs. And then they found out some key cases, and it wasn't that many, but in two of those key cases, they lost a lot of money. So they lost revenue because people were called in and could have fixed something that would have, especially one of those was over a weekend that cost a lot of lost revenue. So what we did, and this actually, number one, the results was that we saved almost $275,000, we didn't save everything. Now, it's important. Sometimes there are reasons why you can't solve the entire thing, right? So we couldn't get to everything, but that's okay. We were able to solve 75%, still a 200-something K savings because we're eliminating those losses, right? The thing I want to show you is that this, with proper tools, we were able to create it in 2 days, right? It took almost 6 weeks for the business to refine and implement it because they're busy. They want to make sure 100%. But this was not that complicated. With the proper tools, we were able to do it in 2 days. So again, the solution was just basically an automated notification and a simple dashboard. If we look at the processes as of how the company replaced Excel and automated, and it's 4 steps, right? Step 1 is they were connecting to Pi every few minutes, determine there's a fault. Now, you have to determine if it was a specific type of fault. You have to work with the engineers, and the business had to make sure to say, hey, because you could have thousands of fault codes. So while it seems simple, on the technical end, it was simple, but on the business end, the engineers and the folks in the business had to work together to make sure that the proper information was queried to understand when a true fault happened, right? So then step 2 was to obtain and aggregate the data, right? We need some data from the PI, we need data from the ISO or the market to say, hey, what are the awards? We needed some labor data. And for this client, initially we had labor data, but then it wasn't as good as we wanted. So initially they used something static, and then they moved to something a little bit more dynamic. So step 3 is basically doing the calculations to figure out lost revenue. So what we did is we figured out lost revenue. So let's say it's a Friday, somebody's not going to be until Monday, it's Friday night, you're going to figure out lost revenue for the next couple, Saturday and Sunday, or partially into Monday. And there's an algorithm for that. And then you look at, hey, is my lost revenue less than the labor cost? Let's say, my labor cost was $1,100 and I'm going to lose 11,000 tomorrow. Well, it's a very simple, I'm going to call that guy out, right? So again, this sounds very simple, but for whatever reason, and I'll walk you through the reason something like this wasn't done, but small things can have large impacts. So automation sent a notification and only sent it if a call out was needed. Everything else we don't care about. You can do analysis later on it and we save the data, but we only send the notification when somebody needed to be called out. And when you send the notification, you can send supporting details, but really most of the time this wasn't needed. They just needed information to say, hey, this was the fault, and hey, you have to come in. And the supervisors were also notified. So again, this was done within a couple of days, took about 6 weeks to refine, because the business needed time, but the actual cost and time to do it was very little, right? So that's what I want to point out. Some of these are very simple to do once you have the team together. So let's really look at why some of this didn't work, right? First of all, with this client, they didn't have the ability to view and explore data from different sources, right? Pi folks had their data, the business had their data, and sometimes they try to put it together, but it wasn't able to be done dynamically. So, they never built an automated solution. And also the calculation and the notification, the business was never able to work with the engineers to get this data and collaborate. And IT was also asked, but IT had 100 other things to do. It was too small a priority for them. So it basically, fell into a state where they just did it in Excel and they lived with it until, we worked with them to automate this. So on your side, if you have Power BI, that can be used for visualization, right? So you can use it to visualize, but that's really all you're going to be able to use it for. You need to do some additional work to get through the underlying data sets, right? That's really the crux of it. The visualization is easy. The notification is generally easy as well. So you can use this, or we have some other tools that we can suggest when we publish some of the recipes. You'll see some of that. We've used our own tool that, integrates everything. For us, it took less than, 9 hours initially. So it was done, within under 2 days.
One of the things I think I want to point out is in the webinar, we are covering few of the use cases. In general, we have done almost 50 or 60 use cases in this field in renewables. But the point is that when you have these use cases, it's very important, as you mentioned, that your tool you're choosing have to make sure you can get data from markets or your Pi or internal sources very easily. And then also you need to have in this use case, you need to make sure there is ability for you to do automations and scripting within the same tool, or else having these kind of problems is going to take a lot of time. And Amit kind of show you some of the other use cases. We chose this use case just to show in the very beginning of our conversations is the knowledge gap, and how do you have a complete stack of your tool which can help these things.
Yeah. So again, the simplest steps are going to begin with, you first should begin with understanding which data that you want. Then you want to explore which data. And one of the things that I really, really want to point out, and it still baffles me to this day, right? It is difficult to get access to all of your different data sources. Whenever we speak to clients, they only have one piece of the puzzle. That's why this is very hard. So number one, what we're suggesting is that you be able to connect to all of your different data sources, connect to Pi, connect to external sources, markets, etc. And step one is just being able to look at the data, right? So if I'm here and let's say I need to look at the data, I see data here and I can scroll down, I could look at the data here. And we're collaboratively looking at a lot of this data, right? Or if I need to go out and I need to get data from EIA, I can look at that data, right? So now the tools are there. If you, within your tool set, if you make sure that you can connect to and look at, give access to the data to the folks that are available, that's going to solve, 30-40% of the problem, right? Then they can move on from the data and say, hey, I need to add this solution or I need to add that solution. And part of what we're seeing with IT is that, for example, when you're looking at data, right? So I can go ahead and I see this data, right? So this may or may not make sense, but then nowadays you can go ahead and just write data in English, right? So show me the data with avail cap equals 0, or, and then you can ask the machine learning and then you're just pressing the button and then it's going to show you the exact data that you want. So a lot of this is easy. Business and IT can work together. And even if we don't have folks that are in the business that, are technical, they can write out a lot of this in English and use that. Definitely we're not saying there's zero technical or IT required. That is going to be important along all these steps, but we're saying IT and business can work together, right? Expose all your data sets, let users get to your Pi data, markets data, even external data like EIA or vendor data. And then that's going to be the first step to doing the solution.
And I think we saw in the last webinar, last client, that we exposed all the NERC data. So now I see clients doing benchmarking, they're getting the NERC data and they're just joining the internal data and doing their benchmark and all those things. So that's also really helps. So now they have data for everything and they're using ML, asking questions in English and kind of getting those answers.
Yeah, and then so again, the other issue is that when you're doing this, right, all these tools will allow visual review of steps. So for example, you could see this is a new Pi job. If the fault is yes, right, then I'm going to obtain all of the data that I need, and then I'm going to send an alert. Now, there's some detail behind this that I'm not going to go to, but visually, that's essentially what it goes to. And then I can say, hey, run it every 5 minutes. So doing this is not super complicated. Again, once you have the process and you work with IT to do some of the tools, you can go ahead and, create these process steps. And behind this, you're going to plug in all your Pi tags. It'll go ahead and grab your Pi tags. And then here you have to say what the name, what the values of the Pi tags are if the fault is yes. So this is just a visual view. Your company may do it differently based on the tools, but as much as possible, we are going to suggest that everything become visual. It's very easy with a lot of the newer tools to do this, so that even the business can do this. They can move steps around if needed. For example, I'll go into, some of these steps that are here and I can, move these steps around. I can do things. I can add a job to do, get ISO vendor data. I want to get adapt2 data. I want to get, KISO data. I can go ahead and add that, right? So these types of tools really simplify. So it's almost like you're using Lego blocks to build, right? And we can do this because within utilities, there's X number of places, there's less than 100 places we'll be connecting to generally, right? So, so again, the final solution was just automation, sending out a notification, and with it, sending out the reports and the details. And that's essentially it. That's all we needed to do. Any questions or comments? Anything else you want to add, Rashid? We'll just review some of the gaps one more time. And
yeah, let's look at the other use cases. I think when we talk about outage tickets or limits, I think that will ask more questions.
Sure. So again, this was done very quickly. We've kind of used our tool. You don't have to use our tool. There's multiple tools out there. The key is really in taking care of these gaps, right? A lot of these are very simple blocking and tackling that if you can overcome those, then you can do this. Any questions from any participants on the call, please let me know. I can do a quick answer if anybody does have questions. All right, so use case 2, we needed to automate solar limits for a client that had 45 plants. This ended up saving over 500 hours per year, and we think that's actually pretty conservative. We think it's going to be a lot more, but right now we're still working on getting the actual numbers. So the current process was that they needed to submit updated forecast solar limits every hour, and they wanted it to be forecasted to be accurate because they were using some just best numbers from what the ISO was doing, and it wasn't as accurate as they liked. So what ended up happening is that I don't know if there's a question in the chat, Rashid, you can check and let me know.
No, it's not. Go ahead.
Okay. Yeah. So what ended up, we found out that, hey, to do this, we actually need to implement machine learning first, right? Because what they needed to do was take the weather records and look at the historical weather and output. If you look at that, that tells you based on the weather, what the output should be. We plug that into a machine learning model. And with that, we were able to create a wind ML model. So once you have the wind ML model, all you have to do is plug in the forward weather and it gives you the forward generation. Once we had that, then it was easy to calculate the limits. And then we just did a process where we submitted them to the ISO. Or in this one, we can actually submit it to another system, which then submits it to the ISO. So the focus of this is going to talk a little bit more about machine learning and how it can be easily implemented. So if we look at the model, right, what we really need is something called the model. And what does a model do? It is going to give for each input, it is going to give you output, or for inputs, it'll give you an output. Here, our input was weather and our output was generation. You could have put in other things such as wind speed, but we'll show you later, they're actually not important. They don't correlate. So when we looked at the client, the biggest gap was that they had data scientists, but they didn't have an integrated or simple tool that could use the internal data, right? If we needed to do this, they needed 3 months and it goes to another internal process, right? So we said, no, we could do this much better because this is, we have the data, we can review it. And we went ahead and did it. The initial one took 12 hours. It took another 16 hours. So over 28 hours, we were able to refine this and get this to a point that was very usable. Now, this was with our tool. You don't need our tool. You can use, Azure, Google, or Amazon. They all have their machine learnings, or you can use off-the-shelf ML tool sets. These get expensive, though. These get very expensive, and this is going to be your best bet, or use a tool similar to ours. So the steps of this are really simple. You have one step where you're going to create and train the model, and we'll talk about that. And then you are going to use the model. So let's talk about creating and training the model, right? Creating and training, step one is obtaining and cleaning the data. So you need some data, historical data, to let the system know that, hey, based on this data, you are going to understand and train yourself, given these inputs and outputs, how the inputs translate into the outputs, right? So number one is you need a clean data set that has the inputs and the outputs in it already. And you get that from historical, right? You have historical actuals in this case. So that's very easy. And then what you do is you say, step one, what do I want to forecast, right? What is my target? And all your tools will generally have this type. If not, when you script it, you'll be setting this up. So you say, hey, my output megawatt is going to be what I'm targeting. And then I can, if I don't, then my next step is to look at the inputs, right? What's going to predict my wind generation? Well, if I don't know, and I have, what I can do is all these tools have something called a correlation matrix, and I can look and say, hey, you know, this output megawatt and wind speed are highly correlated. So most likely it's going to be that. And if we actually look at more details, you'll see here wind speed, you know, except for higher and lower speeds, it's actually very correlated. If you look at wind direction, it's not correlated. So when you have this nice line, that means it's, you know, it's well correlated. Here it's not. So now we know that, hey, I'm going to use wind speed as my input. And then what I do is I train the model. And once it's trained, I can deploy and use the model. So I'll just kind of go into a little bit of,
I mean, there was a question regarding
Sure.
what model. So we are using here a supervised learning, and we are using an auto ML here also. The auto ML, we have in our tool, we have an auto ML, so which kind of uses multiple models, and it chooses the best model. So one of the reasons is we are allowing our business analyst instead of data scientists to do these things. So if you're a business analyst, if you know Excel, you should be able to do a lot of these things yourself, because the machine chooses what's the right model with the data and what you're looking for. So to answer the question, we are using supervised learning for this one. Go ahead, Evan.
Yeah. So again, this is, you know, if we look at this dashboard, all this dashboard is doing is basically getting tomorrow's weather. It's calling the machine learning model. It's getting the output and it's graphing it. So really behind the scenes, you know, this is the model, right? And it's getting tomorrow's and it's calling the model. And if we look at the model, as Rashid said, you know, you go back, it's a supervised regression model. This is our data. And when we were creating it, we created where the data set was. We simply picked where the data set was. And then we went in and we picked the target. Then we went in, we picked the inputs. We can look at the correlation matrix, right? And then if we want, you know, we can do more details within here. We're not going to do that because this is all automated. You can do more things. If you have data scientists, you can, you know, adjust more parameters, but generally, and you know, we're not going to go into that right now, but it's literally that simple to go in. Once you have the data here, you select your items and boom, it's ready. And then when you're ready to deploy it, you know, you're just adding the job to say, hey, get tomorrow's weather. And then I'm going to link it to this job. And boom, you have your inputs, you have your outputs, and then you can just basically create this, or you can send this to other systems, or you can save it or do whatever you want with it. So seems complicated, but it's not that complicated to do. So.
And we are needed right now because we have strict data requirements coming from ISOs. Every 5 minutes current generation, every hour, top of the hour for the next 7 days of forecast values going in. And the renewables market is growing. Your data requirements, if you are in different ISOs, you will see a lot of data requirements coming in the next few months to few years, because that is now taking a huge amount of your capacity, and reliability is number one in their mind. So these things, if you're not there, it will come there very soon if you have these kind of renewable plants coming up.
So again, some of our suggestions is whatever tool sets you use, please. We found that clients that use the tool sets with the auto ML feature, that's helped quite a bit. As we said before, use a tool that's integrated, use auto ML, and our preference is to keep open source as much as possible. You don't want to lock into any vendor. For example, for our solution, we do use AWS. But if we didn't want to use AWS, we could use Azure for machine learning. We can easily switch to them. So we're not using anything that's, where it's going to lock us in, because you're not sure as far as costing, pricing. We really, when we do this, we don't want to be locked in. We want to be as flexible as possible. So really, to summarize, adding in machine learning from what we had earlier, we still need those other things. We need to be able to explore the data. We need to, you have to talk about the data, understand it, which is a non-technical thing, right? Then you explore it, then you do something, a quick prototype to look at it, and then you build further on it. And then we're just stacking in a machine learning tool that can easily integrate. Why this client didn't do it, they didn't have this, and they didn't have the process. It was going to take 3 months, but as we've shown you, this was done within 28 or so hours. It took longer for the business to review, but the actual work was done very quickly, and you can use these solution options. We have our tool as well, but these options work well also.
There was one question. Yes, you can bring your own models also. The tool allows that. So if you don't have to use our models, you can bring your own models in, and you can integrate with the data. So it's very flexible. So you can bring your own models in the tool itself. So.
Yeah, and you can email us, at the apatel@intech Consulting if you have any questions. We could show you how to do that here, or we'll show you how we do it here. But that's absolutely important to make sure that it's flexible enough so that you can bring your own model as well. So, all right, anything else you have to add here, Roshan?
No, we are good. So let's go to the last use case here.
All right, so let me just do a quick time check. Before any other questions before I move to the last use case? All right, so here we're going to talk about automating real-time outages for over 45 plants. So this client has a lot of solar plants, and rather than putting outages manually, when this was done, it was causing a lot of errors because it's not always evident that, with so many inverters, everything going on, that you're actually in an outage or a derating, but it's important for ISO and other reasons. So not only is it a time savings, but it's also helping with compliance and risk, right? Because if you're wrong, then you can get penalized and have penalties, etc. And it can actually throw off your energy offers and bidding process as well if you're wrong. And you could have been running and you lost money because you couldn't run based on your limits, right? Or you shouldn't have been running. And if you didn't do it properly, then you're going to be expected to be running, and you're going to have to buy that back at the market price. So,
and also, Amit, and I see our participants, a lot of NERC GATS users are here. So I think this use case will also help them. This is where the NERC GATS tickets gets created. So when we are bidding outages, that get transferred into NERC GATS events also, where you can go ahead and submit to the NERC systems.
Correct. So again, with this client had multiple plants, millions of rows of data to review, and it was literally just becoming impossible by hand. So the process, and I'm kind of simplified it, but there's more detail just because of the constraints and the time we have. We'll walk more into detail in other seminars with this, but we're going to pull PI or fault data. And this has to be done a very specific way. Really, from a tools wise, you just need to be able to connect to PI and be able to pull it. From a business and IT, again, as I spoke earlier, you need to know which faults and whatnot are important. Usually, when we first start, even though this seems simple, this is just this information is not always there, and it takes a couple of weeks to just get this. But once they start, it's easy to get, right, eventually. So once you have this data, then we have sort of a rules engine and some machine learning built in to figure out, say, hey, is this a reportable outage or derating? And when we walk through this, we'll show you this without the machine learning portion and just show you some of the rules and what you can do. But once you have this, then you look at this and say, you're going to break this process into 2 steps. First is, I'm going to detect a new outage, right? And based on everything, we say, hey, is this a new outage? And then on top of that, you say, is this a new outage for the ISO? Because each ISO, sometimes you don't have to report anything. So we will store every single outage or derating that we detect based on this, and then we'll create the ticket if required. And then we submit, here we're submitting to an internal system because that manages all the ISO data, and that system submits it to the ISO. But you could just as easily submit directly and then submit to this system or not submit, however you want to do it. It doesn't matter. Now, this submitting will require a little bit of understanding depending on how your ISO works, because ISOs have certificates, etc. But we're not going to get into that minutia now. We can, if you have questions, you can email us and we'll show you how you can do that with Microsoft or multiple other solutions and do it fairly easily. So any questions, Rashid? I see an extra comment. I just want to make sure there's no questions.
No, I think
no, okay. All right. All right. So then we're going to do the same process for detecting the existing outage end. But it's going to look for something a little bit different, and you're going to do the same process, submitting everything to the ISO. And really, again, the gaps, why couldn't this have been done, is just the integrated tool sets weren't there, right? Here's some of the tool sets we suggest. Again, you're going to need what we talked about earlier, Power BI and scripting. And then if you don't have that, you can use some Apache-based tools. And then you're going to need some sort of machine learning, whether it's an internal or Azure, Google, or Amazon, which we believe are the easiest and simplest to work with. So once you have these types of solutions can easily be done. And then it becomes a beautiful thing, especially when you have multiple plants. So
one thing, Amit, the reason is the problem we are facing is that we have to look at 5-minute data, and millions of rows are coming up for different turbines and solar inverters. So you need to make sure that it has you have a storage and processing power, and that's the whole thing. Is that now we are looking at every 5-minute, every inverter or turbine data, and that can contribute to millions and millions of rows, coming in, depending how many plants they have, So
yeah. So yeah, again, though, even though the job, it seems like a big job, this was done within roughly a week. It took probably 2 months to really test out because of different things. Folks may have missed pi tags, etc. But the end result was that, you're able to get all these different events, real-time events that could be sent to the ISO, and which inverters are offline. So this is great when you've got 40-something plants and you've got millions and millions of rows to look at every time to be able to automatically do this. It's a really nice, elegant solution that saves a lot of time. And there were some dashboards, etc., built on top of it. This is a simplified view of some of the processes, getting the inverter data, getting the different tags that are required, calling SCADA or Pi, depending on different clients, it's different systems, analyzing it to figure out whether it should be a ticket, and then on the process to create or update the ticket, and then sending it to the external system. And then you can schedule it every 5-minute or every minute or however you want to schedule it. There's, this was a summarized view. That's actually a more detailed process in reality. And results so far, this is still, under observation, but after the initial hiccup, it's been 100% accurate. We don't know the time and dollar savings right now because it's still in parallel production.
So Amit, I think one of the reasons what we are doing is, so we are completely automating the ticket creation. So from tickets to the ISO systems, ticket to NERGAT, so everything is fully automated. So in a way that if there's a problems, people get alerted, but they're not manually entering anything. So the whole idea is that for us, the renewables assets should be fully automated in terms of your limits, ticket creations, and the next few webinars, we're going to talk about predictive maintenance. So all of these things we are seeing is that if you have a what we call plan to generation to the ISOs, if everything is automated, you will only get alerts if something is an anomaly within your process.
Yeah. So yeah, that's it. We talked about walking through, why automation is critical, what are the challenges. We went into a bunch of solutions, and really the whole goal was like, look, these seem like big things, but when you boil it down, the solutions aren't that complicated. And if you can put together those gaps that we talked about, then you'll be able to implement the solution. So any questions, please let me know. Sorry, I apologize for moving through these slides, but also you can email me here, apatel@Intech Consulting, if you're interested. And also, like I said, there's a few companies we're working with. There's no cost to do any of this right now. So we're working with a few clients, would love to get some more folks to join the community and work on the use cases and help create some of these solution recipes. So you can email us here. If not, let me know if there's any questions or comments from anyone in the audience. We've only got a few minutes left, so. All right, I'm guessing folks are probably hungry from lunch. So yeah, if you have any questions, go ahead and email us. If not, really, thank you so much for participating. And Rasha, did you have anything else? Or Dr.
Again, I think the whole idea is please join the community. Start if you're in the renewables area, start looking at these webinars, because we're going to be bringing up different topics, and I think these are very high level, and we're going to go very depth level of topics. In the next webinar, we'll try to do that whole the implementation of NERGATS, then predictive maintenance. We're going to talk about exactly how on the IT side of it. So just if any questions, feel free to reach out to us. And then also, as I mentioned, that if talk to us, send email to Amit and myself, and if you can get access to our tools, we'll definitely give you free access to the tools, which you can install it. And then and I think, and join the community. I think if you join the community, then we can solve a lot of these problems together. So.
All right, great. Thank you very much. Take care, everybody. Adam, you can go ahead and end if you need to do anything special.
Thank you.
Thank you.